raise your hand. Raise your hand if you do not have access to an IV pump at your hospital. Okay, so it looks like that's the case for everyone. All right, so right here is a device I'm going to let's take a look at. It's called a drip assist. And I think that we can connect to the company that makes this and get you some of these. They're relatively low cost, and basically it uses a light beam to translate your drops per minute into cc's per hour, and it also keeps track of the volume of fluid that you've given. You still control the fluid flow with your ruler or with the same way you normally do for IVs, but you can always quickly look up there and see if the IV infusion is still running at the rate that you want it to, and you can quickly change it to a different rate using the same roller mechanism, but seeing the drip assist telling you what that is instead of the labor of basically counting the drops and translating it that way. And it works with any type of IV tubing. There's no special IV tubing that's necessary. Dr. Breed, have you used the drip assist before?
No, never. Never even seen it.
Okay. So some of the basic terminology that we're going to be using are fraction of inspired oxygen, which is we also call percent oxygen or FiO2, and that's a fraction of oxygen in the volume that you're of gas that you're giving. Rate or breaths per minute, how fast the person is breathing, breaths per minute. The inspiratory time, or I time, is the time spent in the inspiratory phase of the ventilatory cycle. So obviously when you're getting a breath, either you're breathing now, you're getting a breath spontaneously, or if it's a ventilator, there's a certain portion of that breath which is the inspiratory time, and a certain portion of that breath which is the expiratory time. And there needs to be a balance, and that balance is called the ratio, the I to E ratio. So the ratio of inhalation time to exhalation time, and then the tidal volume, which is the volume of each breath. Are there any questions that anyone has regarding any of these terms? Raise your hand if you have a question. Okay, so we'll go on. Then there's the peak flow, which is the maximum flow rate used to deliver each breath to the patient. So, and then there's the flow pattern, which is how the average flow is achieved. So the flow is something that we will be visiting for this particular ventilator, because depending on your oxygen source, the amount of oxygen that you give is related to the flow if you are using a low flow method of delivering oxygen to this ventilator. Positive end expiratory pressure, peak, is the pressure to it that you would achieve at the exhalation volume of the breath. So at the end of the breath, before exhalation, then that is the peak, the positive end expiratory pressure. So when you are at the maximum oxygen level that you can give to a patient, the only way that you can increase the amount of oxygen in that patient's blood if the oxygen is not enough, is to increase the positive airway pressure or do something else that increases the mean airway pressure. And so that's why the positive expiratory pressure is important, because there are times with these patients, these COVID patients, when you have the patient on the maximum amount of oxygen that your ventilator can deliver, but their oxygen saturation may still be dangerously low, and you may need to do something like increasing the peak in order to oxygenate them. And then you have the mode, which is the method of support for the ventilator. So we will go over the different types of mode that this ventilator can do, but mainly focusing on those that are relevant to a patient with the COVID infection. And then there's different types of ways that the ventilator can deliver a breath. It can deliver a breath where the ventilator is trying to achieve a maximum pressure. And the tidal volume is a product of that, but you're setting the pressure. Or where you're trying to focus on delivering a specific pressure, and the tidal volume is the side effect of that. So those are the two ways of cycling the vent. And this, we will go over the pros and cons of doing. So some patients who are COVID require one method, some would do better on the other method. So you have to know both methods so that you can know when something's not working with your patient, you're not doing well, how to try the other method. And then the peak inspiratory pressure at the bottom, which is the pressure used to achieve a tidal volume. And then I think that those are the main things out of this particular list. If we go over any of the other ones, then we will elaborate more at that time. I don't want to overwhelm you with terminology right now. So, as I said before, your breath has two components, your inspiration and your expiration. And now we're going to go to some of the ventilator features itself. Is it easier for you guys to see the screen and do this, or is it easier for you to see the ventilator itself? I'm assuming there's only one ventilator in the room, or is there two?
We can do both, Joel.
Okay, so the inspiratory time, turn the ventilator towards me.